Everyone, welcome back to another exciting day of mathematics. Whoop, whoop. Warm-up number 28 is on the screen. How's everybody doing? Good? There's a lot of people going to field trips. What's going on? Maybe we should do one for here, right? Let's go. Do a field trip to the library. Ooh, that would be nice, right, Myra? Yeah? All right. Give you guys some time for that. Copy it. Today we are going to use our Chromebooks. We're going to be exchanging information. Make sure you get those ready. All right. Thank you for sending that in. Some of you are still sending that in. In the meantime, let's go over this together one more time. Warm-up number 28. All right. For number one, we need a GCF for 12 and 20. What is that GCF, everyone? Which is? Is it 5? Oh, yeah, just checking. Therefore, see what I did there, Mario? Therefore. So what can represent 12 using 4? 4 times 3. That is correct. Which means 20 can be represented with 4 times 5. Therefore, what is 4 over 4? It's a giant 1. That leaves us with 3/5. Hands if you got that by yourself. Okay, good. I want you to practice this process, please, pretty please, because we're heading in that direction, not this week, next week, and I just want to get some muscle memory in there. Let's go with letter B. I'm going to break up 6y to the second. What two factors give me 6, Rachel? 2 times 3 times y times y. What is GCF for the bottom two terms? Tell your neighbor. What is GCF for these two? Tell your neighbor, please. GCF. Renzo. 3 times y. That is correct. So that leaves us with x squared, because we took out the 3y. There it is. And this one, 6y divided by 3y is positive 2. Then you make some space here. Therefore, do you see any giant ones? Yes. What is 3 over 3? 1. What else? What is y over y? 1. What does that leave us in the numerator? The 2 and the what? So it's 2y. What do we have in the denominator? X squared plus 2. You can leave it in parentheses if you want, but I'm going to leave it like that. All right, we good? All right, let's go to number 2. Last night had you practice this. We got negative 24, negative 10. What two numbers multiply give me negative 24 that when you add them give us negative 10? Tell your neighbor, please. Yes. Oh, go, Tommy. Negative 12 and 2. Negative 12 times 2 is negative 24. Negative 12 plus 2 is negative 10. So, since this is x and x, we have x minus 12 and x plus 2. So far, so good, yes? Yes. All right, let's go to number 3. Let me make some space here. Is it in standard form? Yes. Group. GCF for these two is x squared. That leaves us with x plus 3. GCF for these two is 4, but since this one has a negative, it's going to be negative 4. Therefore, negative 4x divided by negative 4, that's positive x. Negative 12 divided by negative 4 is positive 3. So what's the same here and here? X plus 3. What's left? X squared minus 4. How we doing? Yeah? Good? You like that spot right there? Yeah. Some people say it's cold, but it's all good, right? You're like, all right, let's go to number 4. All right, we need to solve for y. Help me with this one, Gabriel. Go. We need to leave y by itself, so I do plus 9x plus 9x. 3y equals 9x plus 12. And last but not least, divide by 3, divide by 3. Y equals 3x plus 4. And have you got that? Yes? All right, so we need to write this equation 3 times, but instead of x, a parenthesis. And my first domain, or x value, is -2. The other one is 0, and the other one is 3. So, y equals -6 plus 4, that is -2. Y equals 0 plus 4, which is 4. Y equals 3 times 3 is 9 plus 4, that is 13. All right, we're good? All right, let's go to the last one, number 5. And once again, some of you are like, Mr. Q, this is cake. Chocoflan, let's go. The question. Turn to your neighbor and let them know what is the GCF for 45 and 30. What's the biggest number that can divide 30 and 45? Biggest number. Looks like Caitlin's got it. Very good, Caitlin. What is that number, Mario? 5 is 1, but it's not the greatest one. Yeah. Woo! 15. So how do we represent 45 using 15? We do 15 times 3. That's for 45. Bring down the 2. How do we represent 30 using 15? 15 times 2. Bring down the 3. So, question. What does this one have that this one needs? Because they need to look the same. What does this one need, guys, from over here? The 3. So we multiply 3 top and bottom. There it is. Next, what does this side have now? Look at this denominator that this one needs. Times 2 times 2. So let's rewrite these fractions. Let's see, 2 times 2 is 4. We got 15 times 2 is 30 times 3, that's 90. Let's see. This one is 15 times 2 is 30 times 3, that's 90. And 3 times 3 is 9. Now we have a common denominator, yeah? And then we focus on the numerators. Aww. 4 plus 9 is 13. Good process, yeah? Taking you back in time, elementary. Remember? Sloppy Joes and milk in the bag and stuff. They used to puncture it with. All right, send that in. Copy the agenda, please. Warm-up number 28, quadratic equations. And your homework for tonight, 7 problems. last night you had some problems, yes? You're like, yes, Mr. Q, I had some problems with the problems. Get it? Like, you saw that, Caesar? Problems with the problems. Pretty good, huh? All right. All right, so this is what we're going to do today. Now, for sure, you should have been able to do numbers 1, 2, 3, 4, and 5. The ones that gave you problems were number 6 and number 7. That's if that gave you problems. So I'm assuming you did numbers 1 through 5, so hold on to those, okay? So this is what it looked like last night. Oh, copy the code to access the home plane. GLJ2Y. 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 All right? And those of you following on YouTube, once again, you can access the Nearpod presentation with that, and it would be in there. This is what it looks like from last night. And like I said, number 6 and number 7 might have given you a little bit of problems, but we're going to cover that in a little bit. Tonight's home plane. Let's go, Yulisa. We got this. All right, get a Cornell note ready, please. Get your home plate in front of you because we're going to go over some of those here in class as well. Let me send that to your screen. I'll give you guys some time to set up a Cornell note, please. All right, our objective for today, I can solve and graph quadratic equations. But yesterday, we covered solving it by graphing, by square roots, and by factoring. Did we do that? Yes. Now, for the factoring portion, for number 6, I was trying to see if your noodle was going to pick up on that muscle memory we did with factoring. Hopefully it did. Number 7 is just a tiny bit tweaked where you just need to maneuver around it. So let's start with those. Get your home plate in front of you. And I'm going to go back to the home plate. And I'm going to go over number 6 and number 7. Number 6 and number 7, just to make sure we got those. So I'm going to start with number 6. So, if you did not go over this one by yourself, copy that one. Make sure you write it on your paper so we can do this one together. So we're going to solve this by factoring. Obviously, step 1 is we need to check to see if it's in standard form. Highest degree is this one, 2, 1, 0. For this side, it is in standard form. The other side, it's equal to y. I don't need to worry about the other side because the second step is to set it equal to what? 0, the y equal to 0. So we got 2x squared plus 5x plus 2. Step 3, factor. What number goes on top? Well, since now we have a number here at the beginning, we need to multiply that times the constant. So my top number is 4. Middle term is 5. So what two numbers multiply give me 4? That when you add them, give us 5, everyone. 1 and 4. Are we there so far? However, this one has this number, so I write this above that one and above that one. This is where some of you made simple mistakes on the part K that we just had. Question, can this fraction be reduced anymore? No, so my factors are 2x plus 1. Can this one be reduced more? Yeah, 1 over 2. That becomes x plus 2. But now we set it equal to 0. Do we know what to do from there? Yes, Mr. Q said each one of these equal to 0. 2x plus 1 equal to 0. X plus 2 equal to 0, and solve. Minus 1 minus 1. 2x equals negative 1. Divide by 2, divide by 2. X equals negative 1/2. Minus 2 minus 2. X equals negative 2. Straightforward, yes? Tonight you're going to have another one like these. So make sure you get all the steps. Let's go to number 7. Number 7 read x squared plus x equals 2y. Is that correct? All right. Again, standard form. Second degree, first degree, yes. Don't worry about the y because we need to change it to 0. X squared plus x equals to 0. Now you're saying, Mr. Q, this is not a trinomial and it's not 4 terms. What shall I do? Well, think about it. Let me trigger your noodle. Standard form, we already checked. What else shall we check for? Tell your neighbor, see if that triggered your noodle. What else shall we check for? What shall we check for? Looks like Mariah's got it. Very good, Mariah. I see you. Franco. Sebastian, what should we check for? We already checked standard form. GCF, that is correct. What is the same here and here that both have? X. And that leaves us with x plus 1. So now we have 2 factors, x and x plus 1. So we write x equals to 0, x plus 1 equal to 0. And I solve. Can I solve this one anymore? No. This one, minus 1 minus 1, x equals negative 1. These are my factors. Yes? Did you do it by factoring? You will put a 0 at the end? Oh, that's fine. Yeah. But you use the factoring method? Yeah, that's good. All right. We're good with that? Yes? All right. So, set that aside. We're going to do some more practice today. So before we moved on, though, don't look at your notes. Tell your neighbor a definition for quadratic equations. Definition for quadratic equations. Tell your neighbor. Definition for quadratic equations. Without looking at your notes, type it on the screen, please. What is the definition for quadratic equations? Definition. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, check your screen. You should have written something in regards to 2 variable equations, yes? Highest degree of 2. All right, we covered that already. So we did one of these with square roots and graphing. We did another one with square roots and graphing. Did we do one of these? No, Mr. Q. All right, copy that one, please, onto your notes. Example 1, make a cube. Solve using square roots and graphing. We got 3x squared minus 27 equals y. So, first method is by square roots. Remind your neighbor what to do really quick. What are the first 2 steps? First 2 steps. All right, looks like Mario's got it. First two steps, Mario. Standard form, this is second degree, first degree, good. The y we turn into 0, so this is 3x squared minus 27 equal to 0. All right. Oh, my bad, 0 degree. Thank you. I did that on purpose, see if you guys were paying attention. Right, Mario? That's pretty good. All right. What do I do next? We need to leave x by itself. Now, I'm going to go over this one more time because some of you, I don't know why you guys want to go so fast that you start skipping steps. Don't skip steps, people. Bah. It's like you guys want apps for everything. My goodness. Do the process. Yes. Is it what? I'm sorry? Yeah, for division is when we add the 0. Yeah. All right, here we go. Process. We need to leave the x by itself. So how do I cancel this negative 27? By adding 27 to each side. Therefore, 3x squared equals 27. I still need to leave the x by itself. What is the 3 doing? It's multiplying. What is the inverse? Divide by 3 to both sides. X squared equals 27 divided by 3 is 9. And now, what is this method called? Square roots. That's why the last step we do square roots to both sides. This cancels that. X equals plus minus 3. We good? Yeah? All right. Let's go to graphing. To graph, we need the equation, 3x squared minus 27 equals y. Next to that, we need a table, x, y. And the first step, we said we substitute 0 for the x on the table and on the equation. So, parentheses squared, bring down the 3, minus 27 equals y. Question, what is 0 squared? 0 times 3? 0 minus 27. Answer, negative 27. Step 1. 3x squared minus 27 equals y. What do we do next? Tell your neighbor. What do we do next? All right. Looks like Caitlin's got it. Go, Caitlin. Make the y 0. So change y to 0. 3x squared minus 27. Does this look familiar? Yeah, Mr. Q, we already did the work over here. So just, if you want, just show me with an arrow that you already did the work. So the answer for this one is x equals what? Plus minus 3. So when y is 0, x is positive 3, but it's also negative 3. Let's graph that. X, y, 0, negative 27 is way down here. Then we got positive 3, negative 3. Connect your points from left to right. And then we point to that one and that one and write solutions. Solutions. All right, send me a picture of your notes, please. I want to see what you wrote. All right, so I did one with you like this. Like I said, you had one of those in your home plate, but let's do another one. Copy this one. Example 1 super cube, 4x squared minus 100 equals y. And both, solve it by square roots and solve it by graphing. Do that one yourself. Go. Yes, hands if you got something like that. Very good. All right, for those of you following on YouTube, here it is. Let me zoom in. It looks like plus minus 5, and our y-intercept is negative 100 right here. Negative 5, positive 5. There it is. And they wrote solutions over here in a curve. There it is. All right. Not bad. All right, shall we? Copy. No, it's too easy. Too easy. Copy that one. Example 2 super cube. X squared plus 6x plus 9 equals y. This is using factoring only. Factoring only. I'll give you a head start. All right, you should be just about done. Looks like Monte's done. Very good, Monte. All right, here goes. Step 1, just for the sake of processes, check to see if it's in standard form, second degree, first degree, 0 degree, yes. Then we change the y to 0, x squared plus 6x plus 9. Next, we factor 9, 6, two numbers that multiply to give me 9 add up to 6, 3 and 3. Therefore, x and x, 3 plus 3, all that equal to 0. Next, you set each of these equal to 0, x plus 3 equal to 0, x plus 3 equal to 0, minus 3, x equals to negative 3. We already did that, so x equals negative 3. So therefore, it's only one answer, x equals negative 3. Only one, because it's the same one. Okay? Now, when we get to polynomials and graphing, you're going to see how this goes. We'll get to that when we get to that. But for right now, let's just say that we are going to use the 2, and we'll go from there. All right, hands if you got that. All right, copy this one. Example 2 mega cube. 2x squared plus 13x plus 15 equals y. Do this one together. Here you go. Is it in standard form? Let's check. 2, 1, 0. Yes. So we replace the y with 0. Tell your neighbor what number goes on top and which one goes on the bottom. Talk it with your neighbor. What goes on top, which one goes on the bottom. Be careful with this one because we have a number in the front now. We have a leading coefficient. All right. Franco, what do I write on top? Close. 15 times 2, that is correct. So that is 30. Which means underneath I write 13. So, two numbers that multiply to give me 30. 1 times 30, 2 times 15, 3 times 10, 4 times nothing, 5 times 6, and then they repeat. Which one of those pairs adds up to 13, everyone? Which one, Caesar? 3 and 10, that is correct. There it is. However, look up. don't we have a number here? So we write that over this one, over that one. Question. Can we reduce this fraction anymore? No, so my factor is 2x plus 3. Can we reduce this factor anymore? Yeah, 1 over 5, or my factor, x plus 5. All that equal to 0. Do we know what to do from there? Yeah, set each one equal to 0. 2x plus 3 equal to 0. X plus 5 equal to 0. Let's solve. Minus 3 minus 3. 2x equals negative 3. Divide by 2, divide by 2. X equals negative 1.5. Minus 5 minus 5. X equals negative 5. Hands, have you got that? All right, send that in, please. And you're going to do one of these again by yourself. Copy this one. 3x squared plus 7x plus 2 equals y. Solve by factoring. So, I'll give you a head start. Help me out with this one. Evelyn, what do I do? Go. Standard form, 2, 1, 0, yes, and then? What's that? Substitute for y? The 0, yes. We got 3x squared plus 7x plus 2. All right, pass someone. All right, Kelly, what do I do next? The x, what number goes on top? 6. And how do you get that? 3 times 2 is 6, yes, and then? Yes, so what two numbers multiply give me 6 when you add them give us 7? 6 and 1, hands, have you got that? All right, pass someone. Caitlin, so we're right here. Put the 3 on top of this one and on this one. That is correct because of that. So can we reduce this anymore? To what? 1 over 2. Yes, so my factor is x plus 2. Can we reduce this one anymore? So my factor is 3x plus 1, and all that equal to 0. Pass it to someone. Right here. Individually equal to 0, x plus 2 equal to 0, 3x plus 1 equal to 0, and solve. Minus 2 minus 2, x equals negative 2, minus 1 minus 1, 3x equals negative 1, divide by 3, x equals negative 1/3. Hands, have you got that? All right. From 1 to 5, I'll come to you now with the home plate. Yeah, 5 4s, 5 4s. We got this, right? All right. So, send me what you have, please. Do we have time for one more? Jesus, one more? Jesus said, yes, let's go. Last one. Copy this one. Example MJ2. 4x squared plus 7x plus 3 equals y. You should be able to do that one like straight up in like 30 seconds or something. All right, as soon as you're done, send that in, log out, and we shall be done. Those of you following on YouTube, once again, get some practice in because we're about to move on tomorrow. Bye. See you guys next time. Peace.